Today we are going to be looking at the angle of elevation. First, what is the angle of elevation? Well, before we can get into that, what we first need to understand is that when someone is looking directly out at something horizontally, this is what's called the line of sight. Okay, it's always horizontal and it's always parallel to the ground. Now, if someone changes their eyesight to look up at something, the number of degrees their head has tilted up is called the angle of elevation. And we mark that with this symbol for theta. Okay, so it's angle of elevation is how high you've moved your head up to look at something. For example, if I am standing at the base of a tree, so here's my tree, okay, and this is me here. I'm a little bit further away from the base. I start by looking just directly out at something, okay, just horizontal. That's my normal line of sight. And then I see some movement up in the top of the tree and I tilt my head up to look at what was moving. Okay, that measurement there in degrees is the angle of elevation. So that would be something like 32 degrees. Now, how is this actually useful in real life? Well, we can use the angle of elevation in trigonometry, which can help us find distances, heights of buildings, angles that we don't know. The only thing that we need to know today about trigonometry is what we call the tangent ratio, or as it's most commonly known, tan. Tan is in any right-angled triangle. Okay, so here's a right-angled triangle. I have the side 3, 4, and 5, and let's say that this angle here is 42 degrees. Okay? In any right-angled triangle, tan of the angle is equal to the opposite side over the adjacent side. Okay, so if I'm looking here at tan of 42 degrees, the side opposite 42 degrees, which is 4, goes over the side that is touching 42 degrees, which is 3. So what this tells me is if in my calculator I put tan of 42 degrees, my answer should be 4 over 3. We can use this information to actually help us find a side that we don't know. So for example, back to our tree scenario. Here's my tree. Okay. Now I've measured 5 meters. And that's how far I'm standing away from it. Okay. I look up to the top of the tree and I measure that angle. And that angle of elevation is 34 degrees. How tall is the tree? Okay, so this length here is x. You might be able to see we've got a nice right-angled triangle here. So using the tan ratio, which you might remember, tan of any angle is always the opposite side over the adjacent side. So tan of the 34 degree angle is going to be the opposite side, which is x, over the adjacent side, which is 5. Now using our normal algebraic rules, I need to times both sides by 5. These two 5s cross off, and x is equal to 5 times tan of 34. Now if I actually enter that entire thing into my calculator, so I press 5 times tan 34 and press equals, I end up getting x equals 3.37 meters to 2 decimal places. But I did not take into account in this scenario how tall I am. I started the angle of elevation at my feet, which is not where my eyes are. So Let's say, for example, I know that I'm 1.65 meters tall. I'm going to draw a new diagram. So again, here's my tree. Okay, I'm still 5 meters away. I am 1.65 meters tall. I look up to the top of the tree, and that angle of elevation is still 34 degrees. There's my eyes. Okay, but my line of sight doesn't start at my feet, it starts at my eyes. So here is my right angled triangle this time. Okay, so we still do the same process. This is x, this is 5 meters. So tan of 34 equals x over 5. Multiply both sides by 5. They cancel out. X is equal to tan 34 times 5, which, as we know from before, is equal to 3.37. But this time, that only gives us this length, 3.37 meters. And I want the entire height of the tree. So in order to get that, I need to add my height, my 1.65. So therefore, total height of the tree is equal to 3.37 plus 1.65, and my tree is 5.02 meters high altogether.